numbers. I'm using a slightly different software this time, so hopefully it's all going to work out all right. So first question, and again this is from Engineering Maths 1. So we've got this, and we want to express in polar form. And I'm going to say we're going to do it in radians, because really all angles from now on should be in radians rather than in degrees. I'm going to make the pen a little thinner. Right, okay, so first thing we always do is we draw a little diagram, or Argand diagram of our complex number. So do some straight lines like that. Obviously it's easier for me to do that in this software than it is for you. Right, so 4 along the way would be about here. 4, 8 down the way would be about there. So your complex number is in that quadrant there. Now remember, your quadrants are theta, negative theta, it's radians, remember, so it's pi, take away theta here, and negative pi plus theta here. So this is what I'm going to do to my angle here. Right, so r is the square root of x squared plus y squared. So that's 4 squared plus negative 8 squared. You don't need to put the negative 8 in there. You know if you square a negative number, you get a positive. So that gives you square root of 80. Okay, and you can leave that as the square root of 80. You can write it as 4 root 5. I'm personally going to write it as 8.94. Okay, right, now we know that theta equals the inverse tan of y over x. So theta is going to be the inverse tan of negative 8 over 4. But remember, see that negative. Negatives never enter an inverse cos, inverse tan, inverse sine, because this quadrant diagram of your complex number deals with that negative for you. So you type that into your calculator. Remember, big thing, and it's something I nearly forgot there, put your calculator in radians. So it's inverse tan of 8 divided by 4, or inverse tan of 2, which is 1.107. So I'm just going to put that as 1.11 rads. Okay, so that means that our complex number is z equals 8.94 at an angle of negative 1.11 rads. Now, you don't actually need to write rads at the end of it, because unless you have a degree sign, it's always assumed that your complex number is in radians. Okay, lovely. Just a second little revision question. So exact same thing here. Example 2, put that into polar form. So the question would say express in polar form. So first things first, again, we need to draw a wee diagram. Obviously you can pause the video here if you want to try it yourself. Right now, so that means negative 8 along the real axis, so negative 8 would be about here, I'm saying, and 7 down the imaginary axis, so negative 7. So our complex number looks like that. So remember, our negative theta, theta, pi take away theta, and negative pi plus theta. So that's what I'm going to be doing to my angle, because it sits in that region there. Right, okay, so same thing again. R is equal to the square root of negative 8 squared plus negative 7 squared. But again, you can just put 8 squared plus 7 squared if you want, because you know if you square those numbers, you're going to get a positive anyway. So that gives you the square root of 113, which is 10.63. Again, I'm going to do this in radians. Theta equals the inverse tan of y over x. So that's negative 7 over negative 8. But remember, Negative signs don't come into this at any point. We just treat it as positive because we know that the negative gets dealt with in our quadrant diagram. So the inverse tan of 7 over 8 gives me 0.72 radians. So that means our complex number in polar form, as you said, equals 10.63 at an angle of, and don't make the mistake of just writing that, remember it's negative pi plus 0.6, sorry, 0.72, can't read my own writing. Right. You just work that negative pi plus 0.72 out. Negative pi plus 0.72 gives me negative 2.42. We're just going to say rads at the end. And that's us done. Right, so we're now moving on to our next bit, and that's just again something we've done before, and that is converting polar to rectangular. So this is polar form, or shortened polar form is what this bit is here. Okay, polar form. R at an angle of theta. What that actually means is r cos theta plus jr sine theta, right? That's what polar form really means, but we always explain it like that because we know it's the length of the line r and theta is the angle it makes with the positive x-axis. But this is what it means mathematically. Right, now if you can see our rectangular form is x plus jy. So if I compare these two things here, that tells me that in rectangular, x is r cos theta, and my formula for y in rectangular is r sine theta. So these are my formulas if I want to go from polar back to rectangular. And remember what I said yesterday, you can use the buttons in your calculator, the POL and the REC buttons, to check your answers. But whenever you change from polar to rectangular or rectangular to polar, the working must be shown at all times. Right, so here's some examples. It says express in polar form Z1, which is 12 at an angle of pi by 4 radians, and Z2, which is 10.5 at an angle of 44 degrees. Now, it's dead straightforward. So, let's look at number 1. So, x equals r cos theta. So, x is, r is 12 cos pi by 4, right? Y is r sine theta. So y is just 12 sine pi by 4. Right, so you just type those two things into your calculator. Remember your calculator is in radians for this part of the question. So 12 cos pi by 4 gives me 6 root 2, or 8.49. And this here gives me exactly the same thing, 8.49. So z is equal to x plus jy. So z is equal to 8.49 plus j of 8.49. So it's not a particularly exciting question because x and y come out to be the same thing. And that's obvious because we know that cos of 45 and sine of 45 is the same thing. Right, let's try this next one. Example number 2. I'll remove this because this is obviously what I've done before. Right. So example 2. So remember, x this time is going to be 10.5 cos 44 degrees, and y is just going to be 10.5 sine 44 degrees. You don't need the degree sign in. I'm just doing it because otherwise I'd forget to do it in my calculator. I've already forgotten degrees, right? So 10.5 cos 44 is 7.55. And I'd imagine that the y is very similar just because of how close it was to 45, so it's 7.29. Okay, so let's extend the page. So that means that z is equal to x plus jy. So z is equal to 7.55 plus j 7.29. And that means I've gone from polar form, which was 10.5 at an angle of 44 degrees. So that was polar form, that started off with, and I've went back to rectangular form. So you just need to remember that x is our cos theta and y is our sine theta. Simple as that. But you're going to have to maybe do this 2 or 3 times in a question. You might have to go from rectangular to polar, then do some stuff in polar, and then go back to rectangular. Might be the other way around. You might have numbers in polar form. You need to go to rectangular to add them or subtract them because you can only add and subtract complex numbers in rectangular form. So you're going to have to do this. It's fairly straightforward, but you've just got to make sure that you do it properly. Right. Here we go. Next bit. So multiplying and dividing numbers in polar form. So what polar form does is it allows us to multiply and divide complex numbers easily. However, it is impossible to add or subtract in polar form. So polar form is this great thing because it makes multiplying and dividing an absolute doddle. But adding and subtracting is impossible. So if you've got to add or subtract, a complex number, it must be in rectangular. So you must convert it to rectangular before you can do the add or subtract. Right, now here's our rules for multiplying. So if you've got 2 complex numbers, z1, which is r at an angle of theta 1, and z2, which is r2 at an angle of theta 2, then to multiply them together, you multiply the r values and you add the angles. Or you multiply the moduluses and add the arguments, is what they say. So you multiply the length of the line and you add the angles together. And that just follows on from simple vector work that we've done in higher maths. Okay, and then secondly, the rule for dividing complex numbers, so if I'm dividing z1 and z2, it's exactly what you would think. You divide r1 by r2 and then you subtract the angles or theta. Okay, so we divide the moduluses and we subtract the arguments. Now, one key thing that you've got to remember is that your angle, your final answer theta, has to be between negative 180 degrees and 180 degrees, or between negative pi and pi radians. Now, if we end up with something that's not in that region, so if we ended up with 273 degrees, then we would need to either add or subtract 360 degrees, so it's in the right region. So in that case, we'd take away 360 degrees. Okay, so this is the key thing here. So as I said, if you got something like 273 degrees, that wouldn't be suitable because it's not between negative 180 and 180. So the thing to do is to take away 360 degrees. So we'd get negative 87 degrees. So the angle we would use is negative 87 degrees if that was the angle that we're left with after multiplying our complex numbers in polar form. So let's have a look at some examples. So here we go. I've got three complex numbers here. 10.6 at an angle of pi by 6, 14.2 at an angle of negative 4 pi by 5, and I've got 4.6 at an angle of 11 pi by 12. Right, so let's look at A. So Z1, Z2. Right, so we multiply these two numbers together. So that's 10.6 multiplied by 14.2. And we add the angles together. So that's pi by 6 plus negative 4 pi by 5. Right? That gives me 150.52. And pi by 6. And obviously that's going to be take away this time. Gives me negative 19 over 30 pi. So negative 19 pi over 30. And that's between negative pi and pi. So we're happy enough with that. Right. B. Z1 times Z3. Okay, so we multiply our arguments, our moduluses together. So that's 10.6 multiplied by 4.6 at an angle of, and we add our angles together. So that's pi by 6 plus 11 pi by 6. Again, I'll just remove these wee worksheet things. Oops, done the wrong one. Here we go. So let's just type that in. So 10.6 multiplied by 4.6 is 48.76. And we add these two together, so that's pi by 6 plus 11 pi by 6. It's 11 pi by 12, isn't it? 11 pi by 12. So I've copied that number down wrong. Let me just fix that. 11 pi by 12. And that gives me 13 pi by 12. But that's more than pi. Because 12 over 12 would be 1. So 13 or 12 over 12 would be 1 pi radians. So that means you've got to take away 2 pi from angle. Okay, so we've got 48.76 an angle of negative 11 pi by 12. Okay. Now Z2 multiplied by Z3 is exactly what you would expect. Okay, so can you please try some of those questions on the worksheet on complex numbers? I think it's worksheet 7. But we've done this before. There's another question you can sit and do yourself as well, but I just wanted to do a couple of little examples to remind you. Right,